Hey boys and girls, this is G. Chakraborty from the Department of Chemistry, and you are watching the lecture 19 of this particular course, which is chemistry with the course code of CH101. Right, so we are studying stereochemistry, and this is the third lecture of the stereochemistry part. Okay, so we have come across already about the two lectures of stereochemistry, and we have seen different topics. So first we'll have a little glimpse of those particular things, so that this quick recap will help us regarding the old topic that we people have understood, because that will create a glimpse about today's lecture, right? So stay tuned, and today's lecture will be very interesting, because we have very important topics and our very own topics, right, in this particular lecture today. Okay, so stay tuned till the end of the lecture. And in the first lecture of stereochemistry, we people have seen the different types of 3D structures. Now these 3D representations can be of four type. There is a four projections that we people have seen, and these four projections are nothing but Fisher projection, Newman projection, Sawhurst projection, and flying wedge projection, right, that we people have seen. Okay, now in the second lecture of this stereochemistry, we have seen two very important topics. That is, one is chirality, and the other is optical activity, right? So when a molecule is said to be chiral, if a molecule is non-superimposable on its mirror image, then it is called chiral. In other words, we can say that if four different groups are attached to one carbon, then it is called chiral. Okay, and when a molecule is say optical activity, so generally this chiral molecules are optically active, and they rotate the plane polarized light in clockwise and anti-clockwise direction. Okay, now one of the isomer is called dextro, and the other isomer is called levo. Now here the question comes, what are isomers and what is isomerism? So this is our topic of the day, right, that isomers and isomerism. So stay tuned till the end of the lecture, and this lecture is going to be very interesting, right? So what basically isomerism is, right? This is a very common topic to all of us. We have seen it in our life in different aspects, right? And if you say that isomerism exists in Bollywood, you might be shocking. What am I saying? Isomerism, existence of isomerism in Bollywood. Is it correct? Yes. Judua. Judua means twins, right? There was a film called Judua, right? So they are nothing but isomers, two brothers having the same look, but actually they are different. Similarly, two molecules which have same molecular formula but different structures, they are called isomers, just like Judua. Okay, so arrangement of atoms in space will be different, and their molecular formula will be same, but their structure will be different. This type of things which if we people are having, then they are called isomer. Okay, now that excludes any definite arrangements which are simply due to the molecular rotation. Means if you are rotating the molecule to get a new arrangement, a new structure, then that is excluded, and that will be considered as isomers also, right? Now there is an important thing, that if isomers are having same formula, will they have different properties? That we people will be discussing here. But before that, let us try to imagine that isomers are such things which are having same molecular formula but different structures, and this particular phenomena is called isomerism. Okay, now generally it is considered that the chemical formula of the isomers remains same, but the physical formula remains little bit same or difficult. It varies actually from structure to structure, right? It varies. Okay, now if we go into the details, we'll be seeing that how many types of isomers are. Now isomers is something which is present in organic chemistry as well as in coordination compounds. See, if you remember little bit in class 11 in the chapter 12, that is basic concepts of organic chemistry, there was the thing called isomers, right? Now that was the isomers present in organic chemistry. Okay, after that in class this was in class 11, not in 12. After that in class 12, you people have seen in the coordination compound chapter, most probably chapter 9, there you people have seen again isomers is present, but there the isomerism fact was different. Okay, Now here in organic part isomerism is different, and in inorganic part isomerism is different, but the definition remains same, that is same molecular formula but different structure. Okay, but the characterization or the different types of isomers will be little bit different. Okay, right. So here we'll discuss about the isomers that are present inside the organic part. Okay, so if you see the screen, you can see that broadly isomerism has been divided into two types. One is constitutional isomers or structural isomers, and the other is stereoisomers or spatial isomers, right? Now constitutional isomers, what is the meaning of this particular word? Constitutional isomers are those which are having same molecular formula but different constitution, right? Now this constitution is not Constitution of India. Okay, this is something different. Constitution means construction. Okay, and stereoisomers are a separate cup of tea that also we'll discuss here. Okay, right. So let us move into the more details of this particular structures. Acha, one more thing is to be discussed here, that is stereoisomers may be further divided into enantiomers and diastereomers. Now these diastereomers are of two types, one is cis and the other is trans, and enantiomers are these diastereomers are of two types, one is cis trans, another is conformer or rotamer, right? Now what is conformer, rotamer? That is something we have studied in the first lecture. That it is similar to the Newman projection that we people have understood, and cis trans you people are studying from your very childhood, but we will discuss it here also. Okay, so let us move into the details of this particular things, right? So first we can see that if we move to the constitutional isomers part, we will see that the compounds that have the same molecular formula but different structures, okay, in the manner in which the atoms are linked in that particular compounds, then they are classified, they are actually defined as structural isomers. Okay, the different type of structure will be obtained but the molecular formula will be same, then they are called structural isomers, and these are also called constitutional isomers. Okay, so basically if we go into details, if we will see that there are four different type of structural isomers, right? One is chain, another is position, third one is this functional group, and the fourth one is metamerism. Now if you remember in inorganic chemistry, in the coordination compound chapter last year, we people have seen four different type of structural isomer. One was linkage isomer, another was coordination isomer, third one was ionization isomer, fourth one was hydration isomer. Okay, but here we people are seeing that inside structural isomerism only four different type of structures are there, four different type of categories are there. Rather, these categories are, one is chain isomerism, another is position isomerism, third one is functional group isomerism, and the last but not least we are having metamerism. Okay, now if chain isomers are considered, what we people are having, we will discuss. Chain isomers are those in which there are different chains of compounds. Okay, so what do you mean by chains of compounds? If we go into our basic details of organic chemistry, we'll be seeing that carbon has the property which is called catenation, right? Now what is catenation? The definition of catenation says that carbon is the only element in the periodic table, actually the most abundant and only element in the periodic table, which can form bonds in such a way that it can form different chains or lines. That is, more than 1,000 lakh crore carbons can stay in a particular line having bonding with each other. Okay, this property is called catenation basically. And if I'm saying that okay, 100,000 carbons can be there in a particular chain, and if you are not believing me, just try to remember that in polymers, in plastic, in polythene, in petroleum, this type of compounds are present. Okay, right? If you investigate little bit, you will get the fact. So carbon is a very different type of element which can exhibit this type of property, and which is basically a very good person, right? Joint family. Okay, so it exhibits chains, right? Now if chains are there, then chain isomerism will be there. Now what is chain isomerism? You can see it is written when two or more compounds have similar molecular formula but different carbon skeleton, then these compounds are referred to as chain isomers and the phenomena is termed as chain isomerism. Okay, right? So this is what chain isomerism is. So if we try to understand this with the help of some examples, we will see that one example is given right here, that is pentane, isopentane and neopentane, right? Now what is pentane, what is isopentane and what is neopentane? If we go into the fact that all these three are basically pentanes, right? Okay, so pentane means the general formula of pentane is C5H12, right? So we are assuming that in each of these compounds will be having the molecular formula same, that is C5H12, right? So let us go for the N-pentane. N-pentane means normal pentane, the first one, whether N is not written there, but it is N-pentane actually, you people know it. So the formula is CH3, CH2, CH2, CH2 and CH3. So 5 carbons are there, that is C5, all okay. And there are 3 plus 2, 5, 7, 9, 12, right? So 12 hydrogens are there. So C5H12, the formula is being satisfied and the structure is N-pentane, right? Now next, if we go for the next one, it is isopentane, or it is written 2-methyl-butane. Now what is isopentane? What is 2-methyl-butane? As methyl is present in the 2 positions, so it is called 2-methyl-pentane, and the structure looks like iso, so it is called isopentane. But if we count the number of hydrogen and carbon, again we are seeing here 5 carbons are present, right? 4 in the straight chain and 1 is above 5 carbons and 12 hydrogens are present. So this is also pentane, but this is not normal pentane, this is isopentane. Here the chain is having 4 carbon, in the first one the chain was having 5 carbons, okay? In the third one we are seeing that it is named neopentane, okay? Now here 3 carbons are present in a straight chain, but if you go for the formula, then the formula is here also it is same, C5H12, right? So all 3 are isomers, there is no doubt about it, because they have same molecular formula but they have different structure. One is normal, another is iso, third one is neo, okay? And the chains are also they are different in terms of what? They are different in terms of chains, okay? The first one is a 5-chain molecule, second one is a 4-chain molecule, third one is a 3-chain molecule. So they are called chain isomers and the phenomena is called chain isomerism, okay? Right? So this is what chain isomerism and chain isomers are. Next, let us move into the next category, that is position isomerism, right? Now what is position isomerism? If the position of atoms are different in a particular compound, right, then this particular compounds are called position isomers and the phenomena is called position isomerism, okay? Now here we people can see that we have 2 compounds, one is orthodichlorobenzene and the other is para dichlorobenzene, okay? Now ortho and para, these are different positions, as we people can see. Ortho is 1,2 position, whereas para is 1,4 position, right? So ortho para are 2 different compounds, but the fact is both of them are isomers. Now why they are isomers? Because the formula of benzene is C6H6, right? So the formula of dichlorobenzene is C6H6Cl2, right? If you go for the fact that both of these are having same formula, you will say yes, both of these are having same formula, but in the first one the position of the chloro or the chlorine group, chloride group rather, is in the ortho and the second one is in para, okay? Now when 2 or more compounds differ in position of substituent atoms, here it is this substituent atom is nothing but this chlorine, okay, or functional group. Now this can be said as functional group also, it can be COH, it can be CHO, it can be OH also, right? In the skeleton, carbon skeleton, then they are called position isomers and this phenomena is called position isomerism, okay? So 2 types of isomerism, structural isomerisms are already over. One is the first one, our topic was chain isomerism and the second one was position isomerism, okay? So up next we are having functional group isomerism. Now what this functional group isomerism means, this is our question. So first of all we need to check out what these two compounds are. One is written propanal and the other one is written propanone. Okay, al and one. Now from our prior knowledge we know al means aldehyde and one means ketone, right? Now let us count the molecular formula of this particular compounds. Okay, so left side compound, that is propanal, this compound is having 1, 2, 3 carbons, right? So C3, then in the front it is 3 hydrogen, in the second one 2 hydrogens which are not written actually, but 2 hydrogens are present there, and last one is 1 hydrogen. So 3 plus 2 5 1 6 hydrogens. So C3H6O is the formula of the left side compound. Let us go to the right side. Here also 3 carbons are present, 3 hydrogens plus 3 hydrogens, 6 hydrogens are present and 1 oxygen. So again the right side compound is also C3H6O. So both are isomers, there is no doubt about it, and both are having same molecular formula, there is also no doubt about it. So they are called functional group isomers. Why they are called functional group isomers? Because one is aldehyde while the other is ketone, right? So as they are having different functional groups, so they are called functional group isomers, right? Accordingly, the definition is written like this, that two or more compounds having the same molecular formula but different functional groups are called functional isomers, and the phenomenon is called functional group isomerism. Okay, now this was the third one. Last but not least, we are having metamerism. Now what is metamerism and what are metamers, we people will see. You can see there are two structures, one is pentane 2-one, another is pentane 3-one. Now this if we say that these are chain isomers, the answer will be no, because both are having a 5 carbon chain. Again, if we say that they are position isomers, that is ketone in second position and ketone in third position, yes, that may be valid to some extent. If we say that these are functional group isomers, the answer will be no, because both are having the same functional group, that is ketone. And if we say that they are metamers, we need to know what metamers are. So if actually different alkyl chains are present, if different alkyl chains are present on either side of a functional group, then this type of molecules are called metamers. Okay, now here we can see there are two examples. One is methoxypropane, another is ethoxyethane. Methoxypropane is the first one, where we are having CH3CHCO, that is a methoxy basically these molecules are not methoxypropane and ethoxyethane. These are pentane 2-one and pentane 3-one, so we will discuss about it later on. First of all, let us go for the fact methoxypropane and ethoxyethane. As we can see that the oxy group, that is the oxygen, is present in the middle, and at the left side we are having CH3, that is methyl group, and the right side we are having C3H7, that is the propyl group. Okay, and in ethoxyethane we are having 2 ethyl groups on either sides of the oxy group, that is the ester group, right? Ether group. Okay, now same thing is applicable for pentane 2-one and pentane 3-one also. Here on both the sides, in pentane 3-one on both the sides ethyl group is present, whereas in pentane 2-one on one side methyl is present and the other side propyl is present. Okay, so metamers are nothing but compounds where there are different carbon chains, different alkyl chains on either sides of the same functional group, right? Then they will be called metamers. Okay, so this was all about the structural isomers. So in today's lecture we people have seen that what isomerism is, what are isomers, and we have seen that isomers are those compounds which are having the same molecular formula but different structures, and these structures are evaluated in a different way, right? Now these particular isomers can be basically broadly classified into two categories. One is the constitutional or structural isomers, another is the stereoisomers. So in this particular lecture we have seen the brief about structural isomers. In the next lecture we'll see the brief about stereoisomers. Okay, so in structural isomers we people have seen that it is something which operates with the structure of the isomers, and it is basically of 4 types. The first one is chain isomerism, where different alkyl chains are present in the different isomers, right? And the molecular formula stays the same. In the second one we had positional isomerism, where different type of positions are given to the same atom, right? And in the third one we were having functional group isomerism, where same molecular formula is there, but different functional groups are present in a particular compound. And last but not least, in metamerism we are having different alkyl chains on either side of the same functional groups, right? So these were the 4 categories of structural isomerism. In the next lecture, that is the full and final lecture of this particular stereochemistry of BTech course, right? The 4th one, that is part 4 of the stereochemistry. In that particular lecture, we'll see the details about stereoisomerism and what is diastereomer, what is enantiomer, and what is the difference between them, that we people will be seeing in the next lecture. Okay, so till then, stay safe, and if you face any difficulty, just ring me up, just contact me, and we will sort out with the answers. Okay, so stay healthy and stay safe. Thank you.